Hello everyone. Today let's go through MATLAB programming. This MATLAB programming is now I'm going to teach for the beginners. So if you are a beginner to the MATLAB and this is the right video that you're watching. So MATLAB comes with different version. So the present MATLAB version that I'm using is actually R2007A. There are different even the higher versions also available. So but for my work this MATLAB 2017 is sufficient. So the MATLAB basically used for many of the simulation work in the engineering field. So it's a vast field where you can simulate most of the experiments possibly related to the signal processing, image processing, control systems, as well as robotics. So there are even which are used in mechanical engineering too. So, but what we use the MATLAB present is for the signals, as in so ENC in electronics and communication. So digital signal processing is one such subject where MATLAB is used. So as you open a MATLAB, it comes with the default layout. So most of you are familiar with most of the tools, engineering simulation tools, where you get some uh, common features like it could be debugs or it could be some creating projects. So similarly here also we have few of the basic windows. So when you open a MATLAB, it comes with the three window. As you can see, MATLAB file editing, where you can edit the MATLAB file, that is called as .m file. It's an extension of a MATLAB file, and it comes with the command window where you can give certain commands. We can cross check most of the commands in the command window, and you can see the current directory where exactly you save your files, and the command history, the previous commands, if you are given the command history, it will be shown in the command history. So most of the time we use command window to validate most of the commands, and most of the experiments we can simply cross check with the command window. So if the programming is lengthier, then we go for creating a M file. So whatever command we write it in the M file can be executed individually in the command window. Now the speciality of the MATLAB is the scripting of the MATLAB is similar to the Java or Python or some high level language. It did not declare the data types as what we do in C language. So we have to worry about what data type it is. We can't save the value in any data type. But MATLAB is not the way. So you can create the data type simultaneously when you are making some operation onto it. And functions are very useful here. So most of the functions for your signal processing are available in the MATLAB directly, so you can directly access those M file for your simulation work. And one more plus point is the support. So you get vast support on this particular MATLAB on certain programming. So there are a lot of supports available in the math file exchange. So you can get some M file if that particular protocol, if you are working on certain protocol and that you need some M file help to run the program, you get the support there. So also you can also create some M file for certain protocol and you can upload it to the math work exchange file exchange program. So now let's begin with the actual topic, that is what exactly we can do in a MATLAB under the digital signal processing. So we can plot a signal here, and you can process the signal, we can read the signals. There are many more things that we can do. Let's see in the MATLAB how exactly I can work on a command window. So basic thing, you should be familiar with the background, the the how the data types are actually handled in the MATLAB, so that if you are getting an idea, then you'll get an idea how it was actually handled in the programming. So there are similar loops that we use in C, like for loops, or it could be a while loop, or it could be printf statement. So there are the similar things are there, but in a different way with the different function set. Now let's see this MATLAB or a matrix. So all the data are treated as a matrix. So you declare a row matrix or a column matrix or a multidimensional matrix. For the system, every element is an indexed value in the matrix. So you access the element as an index of a matrix. Let's say I declare a variable x and I assign a value 10. So now you can see that x is having the 10. So x, I can get back the value under the index of 1. So x under the index of 1 is 10. That means I have already declared a value x equal to 10, but it can be even accessed with the value under the index 1. And remember one thing, in the MATLAB there is nothing called index of 0. If you are trying to access any element under index of 0, it gives an error. Always MATLAB, in the entire programming session of the MATLAB, if you are trying to access a value under index of 0, it is an illegal operation in the MATLAB. So make sure that whatever we teach in theory where the index comes with 0 or a for loop comes with 0, but when you are handling data it has to come with index of 1. So let's see how exactly we can declare a value. Let's say x equal to, I want to declare a row vector. I declare x equal to 1, 2, 3, 4, 5, 6. So you need to declare the row vector by giving x equal to, open a square bracket and give the value 1, and don't give comma or something else. You just give a space and type 1 space 2 space 3 space 4 space 5 space 6 and close the square bracket and just enter it. I can see that x is now becomes 1, 2, 3, 4, 5, 6. Let's say I want to see the plot of this particular value 1, 2, 3, 4, 5, 6 under the index 1, 2, 3, 4, 5, 6. So I can simply use a function called plot. So I can use a straight away function plot to plot this value. I can plot it so that now you can see the plot of 1, 2, 3, 4, 5, 6 has come. Let's say now this is a value 1, 2, 3, 4, 5, 6. Right, there is no labels are given for x-axis, y-axis, but you get a continuous plot. Now let's plot this particular value, same value x, in a discrete plot. Now what earlier waveform that you have seen here and this, it looks like continuous, but actually it has joined the line actually. So there is nothing called continuous plot in the MATLAB. You can't make a continuous plot. It is a line joining of the discrete points. So I have to go with discrete plot. So stem is a command used. So under the value x, so stem, it will plot the discrete values. So if I am going to plot it with the stem, you can see that values are plotted with 1, 2, 3, 4, 5, 6. These are called as discrete values. So as you study digital signal processing, actually it is discrete signal processing, where we process only the discrete data like this. So now the indexes are 1, 2, 3, 4, 5, 6 default. So now let's make a time index for the value x. So I would like to make a time index for this value as 0. Under 0 index I get supposed to get 1. With 1 index I supposed to get 2. With 2 index I supposed to get 3. For that I can declare a time index. I will just assume a name called t. T equal to, it starts with 0, colon, 1, colon, 5. So I am declaring the value t as a value starts from 0 with the step of 1 that is declared here, till 5. So you can frame any range, but you should be aware of how many points that you are actually making point. Actually there is no relation between x and t, because this x value is independent, this t value is independent, but I am trying to link those two with the plot of stem. So now I just give introduction stem. You don't know what is stem actually. So in the MATLAB, whenever you don't know any command, you can just go through help. Let's see what is actually stem. So you can just use the command with the help, and you can just use the function detail. You can get the function detail very quickly. Stem is a discrete sequence, or a stem plot, what you say. So when you are plotting, the minimum requirement is actually the variable y. Otherwise, another possibility is stem x comma y plots the data sequence x with the time index y with the time index x. So there are even many other possibilities. They are optional, with the different features of plotting that you can get with the stem. You can go through this. Even there are documentation available on the stem, so you can go through this for more possibility on getting different features on the plot. So let me go through the function. I can use up and down arrow, so see what are the commands that I have entered. So now let me plot stem again. So as time index is t comma x, so t gives the time index and x is the plotting values actually. So if I am going with this function, you can see that I will get the plot. Now you see, with the 0 index I am plotting 1, with 1 index I am plotting 2, with the 2 index I am plotting 3. So this is how I can plot a wave with the stem plot. So let's go with the plotting a sine wave. So you want to plot a sine wave, so you can declare a variable y here. So y is a value can be taken with the sine function. So I can define a sine function here as 2 into pi into 2 pi f. Let's say frequency is 100 into, let's say, t. So I'm plotting the value of for a y with the sine function 2 pi f t. T is already declared as 0, 1, 2, 3, 4, 5. So those 0, 1, 2, 3, 4, 5 are actually taken, and you are actually plotting the value of y. So if I'm going with this way, I get these values as y. So values for the y is thus 0 and certain value. Now I don't know what frequency it is, but actually these are the values at different interval of time period with t 0, 1, 2, 3, 4, 5. If I'm going to plot this, let's say use a stem plot again as t comma y. So I'm going to plot this wave. See here, it won't come as a exact sine wave. You may surprise why it is not coming in the sine wave. Actually we are plotting a different instant of the sine wave, not on a single period. We are actually taking with the different time width, because if we see sine 2 pi f is 100 hertz, whereas 100 hertz is having a time cycle, time period for 100 hertz is generally around 10 millisecond. So 10 millisecond, but what time I am considering here t is 0, 1, 2, 3, 4 seconds. So they are not in one single period of this particular sine wave. So you are not able to get actual plot of sine wave. So we will see how exactly we can plot a sine wave in the next session. Thank you.